Hi, my name is Esteban Portillo.
And my name is Gutierrez.
And we're part of Team Aeolus. We picked the wind turbine project because we felt that it used all the variables that the school taught us in mechanical engineering. We used structural analysis, we used fluid analysis, and we did a lot of various other calculations that was able to help us get the ultimatum goal of producing electricity. Unfortunately, 1.3 billion people in the world do not have access to electricity. However, we decided that we can design something that can produce clean energy where it's small and affordable.
So the basis of our project is to create a wind turbine that will be self-sustainable and not need outside sources to make it work. One of the issues with vertical axis wind turbines is that they cannot self-start. And since we want this project to be self-sustainable and able to work anywhere off the grid, we must design a way to get this wind turbine to self-start. So what we had to do was create a pitch mechanism that will pitch the airfoils into the wind and allow the wind turbine to start on its own.
As team leader, I was in charge of procuring materials and labor for our fabrication process.
My role on the team was to design, analyze the wind turbine, and also participate in the fabrication of the wind turbine.
Hello, I'm Cristian Gomez.
I'm Ricardo Garza.
My role in the team sort of focused on all parts of the aspects, but mine was more prominent along the manufacturing and fabrication.
I also worked on the manufacturing. I worked with our sponsorship and managing our budget.
Now, considering a project of this scale, it was comprised of multiple components. So we divided these components into separate manufacturing processes. First being the airfoils. In the airfoils, we used basic styrofoam body connected with the wooden planks on top working as caps that gave us a sort of position to fasten the airfoils to the actual system. And then we embodied the airfoils using fiberglass techniques to sort of give it a more structurally sound body.
So our frame is composed of L-angled steel bar, and it was welded together with vertical supports to support our overall system.
We use finite element analysis as a software to understand the theoretical process and understanding of our wind turbine before it was made. We used software that was available in university, and with me and also my teammates, we were able to understand exactly what we were getting into before even fabrication.
In order to predict the performance of our wind turbine, we used ANSYS software in order to run computational fluid dynamic analysis on our wind turbine and see how it would react in certain conditions. We also used MATLAB in order to run numerical analysis and see our optimal pitch angle for our wind turbine.
Next was the variable pitch mechanism. Now, this mechanism comprised the actual heart and soul of the project. Without this, our project would not actually be operational. So this comprised of aluminum flat bar links connected to an offset mechanism, which was comprised of two stainless steel cylinders welded onto a stainless steel block, which was then created into a single system connecting a wind vane, allowing the wind vane to actually pitch the links when connected to the entire system. As for the shaft design, we used an 82-inch 1040 steel 1.5 diameter steel shaft that was provided to us by Houston Bearing Supply. We then had the shaft turned down exactly 2 inches where we would actually assemble the offset and VPM itself.
So we used a teg meter, a multimeter, and ammeter to measure our wind speeds and RPMs, volts and amps respectively, to calculate our power outputs.
Our project was able to cut in at 6 miles per hour wind speeds and able to produce 120 watts at 17 miles per hour. This allowed us to produce enough electricity for what we wanted to accomplish. Initially, we wanted to be able to power villages, small communities that just needed electricity for everyday use.
As we designed our turbine, we had to create something that was easy to manufacture, easy to assemble, and easy to use.
What I learned throughout my experience of this project is sort of how to implement my knowledge and skills that I obtained in my degree into a real-world application, but as well also in a team environment in which we're able to feed off of each other's skills and also help each other where we need help.
So I learned the importance of working together in a team environment, being able to manage our expenditures, and managing our budget accordingly to spending.
This project has given me a lot of engineering and project management experience. I've been able to learn and understand how to organize, meet industry professionals, and get the project going while meeting deadlines.
This project allowed me to apply what I learned in class into a real-world project, such as choosing the proper materials for our design and confirming our hand calculations through FA16 softwares.